This is homework number 5 in section 4.2. The question is regarding finding least square regression line, and once you get the numbers, you're trying to analyze what's the meaning of those numbers. Before I start working on this question, I would like to first give you a little introduction of what is linear regression or least square regression. Okay, this is a set of the data I pulled out from number 5 of 4.2. The table actually gives you 11 correspondence between the heights and the head circumferences of 11 children. And if we do a scatter plot, we got 11 points there because each x and y makes an xy coordinate that forms a point on the xy coordinate. I'll show you how to use a scatter plot. I'll show you how to use StatCrunch to do the scatter plot in a little while. Okay, so once you have those 11 points out, our purpose is trying to find out a line that maybe fits in all those data the best. Okay, so we learned that in algebra, a straight line actually can be determined by the slope, which is m, and also the y-intercept, and then the equation for that will be mx plus b. This is the function for a straight line. M is the slope, and then b is giving you 0, b is the y-intercept, which is that point. Okay, that point will be 0, b. Okay, we've already know, or you say mathematicians already find out, in the least square regression, your m is equal to r times sy over sx. This is how you find out that slope by hand. And then the formula is in your book. Okay, r is the correlation coefficient, and sy is the standard deviation of the y value, which is the standard deviation of all those numbers there. Okay, and Sx will be the standard deviation of your first column, which is the height there. Okay, so this one has S, this is your Sx, and also you can find out the mean, which is x bar. For this set of data, you actually can find out Sy, that's the standard deviation, and you can also find out y bar, which is the mean for this set of data. Okay, so that's how you find out the slope. In order to find out the y-intercept, the formula will be y bar minus m of x bar, and the just mentioned y bar will be the mean of your second column. That's the average of the head circumferences. M is the slope we just found out using this formula, and x bar is the mean of your first column. That means the average of the heights. Okay, so that's how you do it by hand, but we mostly will be doing that using StatCrunch in this course. And then we're not really doing much about introducing the backgrounds or say the reasoning why these two formulas are like that. Okay, but if you want to know the reason, you can refer to more reading there. Okay. So here is the picture I got from StatCrunch using fitted line. So that's our least square line. Okay, one more concept I want to introduce before I go back to the StatCrunch is something called the residual. Okay, so for example, if I have x is equal to 27, that means your a child's height is 27 inches, then its corresponding head circumferences from our observation will be 17.5. Okay, and you can also read that from the table. See, x is equal to 27, your y value is 17.5. So that's this point telling you that 17.5 is called observed value. Observed value. But from our least square regression line, we also find out if you have x is equal to 27, I have a corresponding y value here, right? you can roughly reading the graph to say, oh, maybe that's a 17.42. But how do you find out exactly is based on what we have that for the equation. Remember, if we find out the equation, that will be y equal to mx plus b. Then what you need to do is you have to plug in x is equal to 27. You have to plug x is equal to 27 into your regression function, which is mx plus b. By now, you should already find out m and b. So plug in the 27 into here, you should find out the corresponding y value. That y value is called predicted value, because using our regression line, we're predicting how big is the head circumferences when the height is 27. And then from the picture, you actually can notice there is a difference between the observed value and the predicted value. So if you use observed value minus the predicted value, that distance is actually called the residual. Okay, so each point actually have a residual, right? Observed value minus expected value. That one is observed value smaller than the expected value, so that residual should be a negative value. That will be a positive value. This is also a negative residual, negative residual, negative residual, and so on. So least square regression actually is minimize the residuals there. Okay, so let's go back to the StatCrunch looking at our real question there. Okay, in this question, part A is asking to find the least square regression line treating height as the explanatory variable and head circumferences as the response variable. Let's take a look at the data. It should give you an x coordinate, which is all the heights, and your y coordinate are all the head circumferences. X coordinate is your explanatory variable, also called independent variable, and y coordinate is your response variable, also called dependent variable mathematically. Okay, how do you find out regression line? Which is you need to find out this number in front of the x. That should be the slope of your linear line, and then the number behind it should be the y-intercept. So open the data in the StatCrunch. Now you'll see these two columns shows up here, and you do stat, regression, simple, linear. Pick up your x coordinate to be the heights and y coordinate to be head circumferences. Usually if you just want to do the regression, you don't need to select anything. But in here, I'm going to pick the fitted line plot, and I would like to save the residual because we need to use it later. Control and then residual. So these two are picked. And compute. Okay, let me open that up. You'll see this line is really important here. It says head circumference inches y. So y is the head circumferences. It's equal to the following. So be careful. The x is actually on the back here. So the number in front of it is actually the slope, because x representing the height. Okay, so that slope should be goes to here, which is 0.162, rounded to 3 decimals, and then 13.052 is your y-intercept goes to the back here. So let me try that. 0.162. And the next one is 13.052. 13.052. Enter. Okay, excellent. So that's how you read that line. And then make sure you understand what's the meaning of the slope and what's the meaning of the y-intercept. And then that's the following two questions. It asking you interpret the slope and the y-intercept. So the slope means every unit of the x change will make 0.162 of the y change. So in here, x representing the height, and y representing the head circumferences. So basically this means every 1 inch of increasing of your height is going to make 0.162 inch change of the head circumferences, which ended up to be, I think, is answer D. For every inch increase in height, the head circumferences increased by 0.162 inch, okay, on average. Okay, well done. Okay, next one is for y-intercept. Y-intercept actually is where the line is crossing y-axis. Or the other way to say that is when your x is equal to 0. So when x is equal to 0, in this case means there is no height. Height is equal to 0, right? So if a child has no height, the equation actually gives you the head circumferences will be 13.052 inches. That does not make sense, right? Because if a kid has no height, how come it has head circumferences? So I believe the answer is it is not appropriate to interpret the y-intercept in this case. Okay, that should be E, and check the answer. For part C, use the regression equation to predict the head circumferences of a child who is 24.25 inches. So what is the regression equation? It is actually the one you just find out from part A here. Okay, that's your regression equation. And then it says when the child is 24.25 inches, that means your x value is 24.25. So in order to calculate out this number, you actually use your calculator to type in 0.162 times 24.25 plus 13.052. That should be your answer. Okay, I'll show you how to use your StatCrunch to do this question. You can open that in StatCrunch. I think I lost that data. Okay, load stat and regression, simple linear. Okay, I still need to pick your x value and y value. Now notice here is a prediction of the y value. So I'm going to type in 24.25, right? Double check that's the right number. Okay, yes, 24.25. And I need to compute. So notice this window actually shows you an extra thing here. It says x value 24.25 and your predicted y value is 16.987. Rounded to 2 decimal places should be 16.99. Okay, so okay, well done. Okay, so that's how you use StatCrunch to do that. Notice we mentioned what is the residual. So the residual is your observed value minus your predicted value. Looking at the table here, you'll see part D actually asking you for the 24.25. So we do see that in your table 24.25 and then corresponding head circumferences should be 16.9. That's what you measured for one of the kid. So that's from your observation. And 16.99 here is actually coming from your calculation or say from your prediction. So you should use your 16.9 minus the 16.99 to get the residual. So the residual is a negative number because 16.9 minus 16.99 should be negative 0.09. If the residual is a negative number, so that means the head circumference of that is below average. Let's check the answer. Well done. Good job. Okay. So part E asking you to draw the least square regression line on the scatter plot. Here is how you do that in StatCrunch. Okay. Sorry, I have to open that again and again. I thought there's somewhere. Okay, you can do stat, all those again, regression, simple linear, and x and y. Now, the thing you need to do is fitted line plot. And you can also select a save residual because we need to use that next. And then compute. Notice it gives you 2 pages. First page is mostly the same as what we had. And if you use this arrow button, it's going to give you the fitted data here. So compare that with what you have here in your 4 choices and see which one is the most close to one. Okay, part A, not, right? Part B looks very similar because you see that 3 dots here and the line. And just do a quick look. And part D, at least this 2 points on the line and that 2 is not. So it should not be the D, and the C definitely not because that line is actually horizontal. So I decided to pick B. Check the answer. Nice work. Good. Remember I did pick save residual, and you notice there's a new column actually coming out. So that is what we did, is saving for each point. The residual is corresponding to the observed value minus expected value, and then the expected value, or say predicted value, is coming out from your regression equation you just found out. Okay, I think we still have one more part left there, right? Okay, last part. Notice that 2 children are 26.75 inches tall. Look at the data here, 26.75, 26.75, but one was 17.3 inches head circumferences, the other one is 17.5. They are different. So how can this be? Okay, it's normal because you can have 2 children, same height, but different head circumferences, right? So basic on that, I should choose, let me see. For children with the height of 26.75 inches, head circumferences vary. I think that's the answer. Check answer. Okay, good. And then that's the last part. Would it be reasonable to use the least square regression line to predict the head circumferences of a child who was 32 inches tall? Okay, so look at the heights here. You need to look at the maximum and the minimum. The minimum is, I think it's 24.25, and the maximum height is 27.75. And then 32 inches is outside of this boundary, so it will not be appropriate. So we select no. The height is outside the scope of the model. That's your answer. Check answer. Fantastic. Good. We are done with this question.